today we are going to study science. In the science, we are going to study 10th standard. The chapter is light, reflection and refraction. Now, in the previous standard, you have learned about different phenomena of light, just like twinkling of stars, formation of rainbow, and also the image formation in front of mirror. All these phenomena are related to light. Now we can see any object because of presence of light only. When light is there, light falls on the object and the rays which are reflected from the object enter to our eyes and we can see the object. So if light is not there, we are unable to see anything. So let us more discuss about the light. Today we will see reflection, means we will just revise the reflection of light, then formation of images by spherical mirrors, refraction and the formation of images by the lenses also. Just we will go step by step. Now let us recall reflection of light first from the previous standard. If you remember, in this particular topic, we had taken example of formation of our image only. Means we are standing in front of a plain mirror, so we see our image. Now, which kind of image is this? Definitely this is virtual and erect image, and there are many characteristics of these images. So we will first recall the laws of reflection, and after that we will move towards the characteristics of the images. Now, if you remember, first law of reflection is incident ray and reflected ray are equal in measures. Second law was incident ray, the normal at the point of incidence to the mirror, and reflected ray all lie in the same plane. These were the two laws that we had learned. Now, just recall the characteristics of the images. You can see the image formed by a plain mirror is upward image. Means if I will give you the example of candle, you can see the image of burning candle. Flame means suppose the original candle is my object. So in the object, flame is upward. In the image also it is upward. So the image formed by the object is upward. Second was the size of the object is equal to the size of the image. Third characteristics was the distance of the object from the mirror is equal to the distance of the image from the mirror. That was the next characteristics. And also I had given you an example that I will repeat here. If you raise your right hand in front of the mirror, it seems that you are raising your left hand. That means we can see our right portion looks like left portion and left portion looks like the right portion. That means in the plane mirror, the image is laterally inverted. So this was our next characteristic. So all these factors we had studied in the reflection by plane mirrors. Now there are some mirrors which can in which we can study the reflection. There are spherical mirrors. Yes, here I will give you an example. Take the spoon by which we used to take the curry. Then that spoon have two surfaces, one inward surface and one outward surface. Now try to look your face in inward surface, move it, and now just change the surface and look at the outward surface which is bulgy from the outside, and try to do the same thing. Means look at the image and try to move the spoon. Image changes accordingly. Now this portion of the spoon, means this portion of the spoon, actually we can say it is a portion or a part of a sphere? Yes, definitely. If you will continue that thing, it is acting like an arc. So if you continue means you will complete the arc, you will get the circle, or you can say you will get the sphere here. So these kind of curvy images, means curvy lenses, are called spherical mirrors. So today we will learn about more spherical mirrors. In the spherical mirrors, you have two types of spherical mirrors. One the mirrors in which the inner portion is tilted. It's like this, you will say. These are known as concave mirror. Means image is formed on this side and opposite side is painted. So this is concave lens, and similarly you have concave, means convex lens. This is concave lens, this is convex lens. Now here I will say it again. A spherical mirror whose reflecting surface is curved inwards, that is, it is faces towards the center of the sphere, is called a concave mirror. And similarly, a spherical mirror whose reflecting surface is curved outward is called convex mirror. So here you have concave mirror and this is convex mirror. Now I had given you example of the spoon. The inward surface of the spoon will act as a concave mirror and outward surface of the spoon will act as a convex mirror. So now we will study the characteristics of these mirrors and also the images formed by these mirrors. Now, in order to study the characteristics of spherical mirrors, here I have drawn two figures that you can see. First, image formation by concave mirror, and second, image formation by convex mirror. Now, you can see here, for in the first case, I have concave lens. Beam of parallel rays is incident on concave mirror and all the rays get reflected and concentrated in a single point. Similarly, here in the second case, it is convex mirror. Beam of parallel rays is incident and gets reflected in the same direction, but the thing is that all the reflected points, if we extend towards other side of the mirror, it seems that all are emerging from single point, that is F. Now you can see here are some points. I named those points. Now we will see which are those points and what those are called. Firstly, the center of the reflecting surface of the spherical mirror is a point called the pole. As you can see, this is my curved surface, that is concave mirror here, and it has one central point and this point is known as pole. So first point on the mirror is pole. We will write about it. The center of the reflecting surface is called the pole. Obviously, it is in the case of spherical mirror and it is denoted by capital P always. You can't denote it by another letter, you have to denote it by capital P. Now, in the second part, you can see all the points are emerged from this seems to be reflected in a single point. This point I have named by letter F. This is known as focus. Now here we will write our second point, focus. The all reflected rays by a spherical mirror coincide in a single point called focus of the mirror. It is denoted by capital F. Again, you can change this. Now, we had considered this concave or convex lens means spherical mirror. Definitely, it is a part of whole sphere. Means if we are talking about the sphere, definitely that sphere will have some center here. So here in this case, you can see I have denoted this distance, means distance of the center for this particular spherical mirror by C. So C is known as the center of the mirror and it is denoted by C. So let us write about this center
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. Make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger. The night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how? He got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
So, the center of the spherical mirror which is the part of the sphere is called, it is not only the center, it is center of curvature, called center of curvature, because we are talking about the curved surface. That's why it is called center of curvature, and it is denoted by capital C. Then next you can see straight line here which is going through the mirror. This straight line, I can say it is CP. It is actually the principal axis. We are talking about the principal axis. On this principal axis only, center of curvature, then the pole of the mirror, and also the focus lies. So let us write principal axis. It is the horizontal line passing through pole and center of the mirror. And lastly, it is very important here, you can see we have one distance here between point F and P. For every spherical mirror, you will have this distance, and you will observe that for every spherical mirror, whether it is concave or convex, this distance will fix. Means if you are taking one mirror and you are trying to find out its focus again and again, even if you change the object, your focus will not change. For a particular mirror, the focus is fixed. That means the distance between point P and F is also fixed. This distance is called focal length of the mirror. And what it represents, that I will show you. Let us write about focal length. Now focal length is length, so it is denoted by small f. We write it is distance between focus and pole. Now, in order to explain you what is focal length, I will give you one example. Here, take one mirror. It can be concave or it can be convex. You will take it mirror. Then, don't look at directly to the sun. Just place mirror in this way in front of the sun, so that sun rays will come here and the sun rays will reflect it at a certain point. Now that certain point, to catch that certain point, you can use the screen. Now move your lens on screen. After some time, by moving the screen, you will get a sharp point, this sharp circular point. This is the distance where you will stop moving the screen. Now hold like this only, screen as well as the lens, mirror. After some time, you will see that at that sharp point you will have some smoky structure, means your paper will start burning firstly with smoke, and after that instant the paper will start burning with fire. So why this happened? Actually, the distance between the mirror and the screen is the focal length of the focal length of the mirror. In this case, actually that sharp point was nothing but it was image of the sun, and because of heat coming from the light rays, the paper start burning. Now why this is happening? Because all the rays are concentrated at that point. All the reflected rays are concentrated at that point. Hence, all the heat energy coming from rays at is concentrated at that single point. That's why the paper start burning. So this is the example how we can find the focal length, and also it is very simple. You can take the mirror again, and you can also take the tube light or bulb, which is light sources which emit light. You can take any one of them. Repeat the similar experiment. Means you will try to capture the object image, object rays coming from the object, and try to figure out its proper image. Means image should be clear, it should not be diminished. So you, after formation of the image, you will measure the distance between mirror and the image. That will be the focal length. And as I explained earlier, for every mirror the focal length is fixed. It will not change with time. It can change with the object distance. Again, obviously you have to fix your object, and accordingly you can get the focal length, but it will not change from circumstances to circumstances. For a fixed mirror, the focal length is always fixed, and it is denoted by small f. Now let's move forward. Now in the next part, I have to explain you one thing remained. Actually, if you look carefully, distance between C and P, actually C is the center, P is the pole. So distance between the center and pole will be definitely the radius of the mirror, and that we will denote it by capital R. Now if you look carefully, you can see your focus, that is principal focus of the mirror, lies in the midway of CP. That means you can write R is equal to 2F. Means for every mirror, the focus, means principal focus of the mirror, lies in the midway of center of curvature and pole of the mirror. So in the next case, the portion Mn is actually the small part of the sphere. So this portion Mn is known as aperture here. So now we will see how we can form images in the different way, having different cases here. In the first case, a ray parallel to the principal axis after reflecting will pass through the. Now in this part we will see the formation of images on both concave and convex lenses in different cases. Here we will discuss the first case. Here in this case, a ray parallel to principal axis after reflection will pass through the principal focus in case of concave mirror, or appear to diverge from a principal focus in case of convex mirror. Means I will draw it here for you. I was talking about a ray which is passing parallel to the principal axis. Means in the first case here I have, you can see, this is concave mirror. This is the principal axis. Now I am taking a ray. Suppose one thing you remember, this distance means the distance between the focus and the pole must be equal to the distance between the principal axis and incident ray. So this is the incident ray which is parallel to principal axis. Now this will reflect. So you will see here, it will pass through focus of the mirror, and here will be definitely your center of curvature C. Now if we draw a perpendicular from center of curvature to the mirror, this angle will be definitely the angle of incidence of the ray, and this angle will be the angle of reflection. So I and R I am denoting here. So this is the case for concave lens. Similarly here I can draw the similar figure for convex lens also. Now I have this convex lens. Here you have principal axis. Here is your principal focus. Here is your pole, and here you have center of curvature. Again same condition, means we are taking one parallel axis to means parallel incident ray to principal axis, and the distance between the two parallel lines will be equal to the distance of PF. So suppose this is my incident ray, and definitely it will get reflected here somewhere. Now, and it will appear that it is reflected from the focus. So here will be my angle of incidence, and here will be my angle of reflection. And if you will connect this, it will come to C. So this is the first case, means these diagrams I am drawing just to show you how rays can get reflected if the cases are different here. Now here in the second case, a ray passing through the principal focus of a concave mirror, or a ray which is directed toward the principal focus of a convex mirror after reflection will emerge parallel to the principal axis. This I will show you by figure. Now you can see here again I am taking concave mirror. Here you have your principal axis. Now I am not taking condition that the ray must have this parallel distance between the ray of incidence and the principal axis equal to focal length. This condition is not taking here. Just the thing is that your ray here, incident ray, is not parallel here. Means it can incident at any angle on the mirror. So you will see that after reflection this ray will become parallel to principal axis. So suppose this was your focus and this was your center. Again similar thing is happening for convex lens. This is my convex lens. Now you can see, suppose this is the principal axis, this is your pole, this is your focus, and this is your center of curvature. Now you will see that this is your incident ray, and after reflection it will become parallel to principal axis, and you can see that it is, observe that if it is emerged from the focus, Here also same thing that you can see. Now, in the next part, we will see another case of incident ray and reflected ray. So it will be my third case. It is a ray passing through the center of curvature of a concave mirror or directed in the direction of the center of curvature of a convex mirror after reflection is reflected back along the same path. This is shown by figure. You can take. Now here light rays come back along the same path because incident rays fall on the mirror along the normal to the reflecting surface. That I will show you here. You can see this is my concave lens. Suppose this is the principal axis, this is pole. Now condition is that, suppose this is your focus and this is center of curvature. It is given that your incident ray is passing through the center of curvature. Means like this you will have. And this is incident ray, and it is observed that it will reflect from same path. Means incident ray is traveling, means reflecting ray is traveling on incident ray. So this is the case of reflection here. If the incident ray is passing through center of curvature, same thing is happening for the convex lens. Now, suppose this is your focus and this is your center of curvature here. Now, you will observe that, suppose, now you will say that how we can do this. Means, suppose I am taking one ray like this. Means, it is passing through the center of curvature here. It will reflected back in the same direction along the same path. So this is the case, and in the next case we have a ray incident obliquely to the principal axis towards a point P, that is pole of the mirror, on the concave mirror or on a convex mirror, is reflected obliquely. The incident and reflected rays follows the same laws of reflection at the point of incident P, making equal angles with the principal axis. This I will show you with diagram. Now here you have a concave mirror. Now condition is that, suppose this is my principal axis P, and your condition is that your incident ray is falling obliquely on the principal point, means pole P, like this. This is your incident ray. So this is incident angle I. You will see that this ray will get reflected obliquely but from the lower side, making angle of reflection R for concave lens. Now similarly for convex lens, suppose this is your principal axis, this is pole, then here you will see, suppose this is the incident ray I, the reflected ray will be like this. making an angle of R. So these are the different cases where rays are reflected. Means I'm showing you this because we have to draw the diagrams for concave and convex lens by changing the positions of the object. So you should know that if ray is falling parallel, from where will it pass? If ray is falling obliquely, what will happen? If ray is passing through the center of curvature, how it will get reflected? And if ray is obliquely, means ray is incident obliquely but at the pole. The ray of incident is in oblique direction but at the pole, then how it is reflected. So these are 4 cases here. So now let us see if we change the position of the object for a concave or a convex mirror, how the images are formed.
No more spending your energy and money on coaching classes or missing classes for rain, for rally and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now here I will show you the different cases of incident rays on both concave and convex lens. Means I am taking different situation for incident ray and we will see that how is it reflected. Now in the first case, your incident ray is parallel to principal axis. Is parallel to principal axis. In the second case, your incident ray is passing through focus, that is principal focus. Here, third case we have, if your incident ray is passing through center of curvature.